In this video, we are going to solve this bridge network where we have a sine wave, which is the input Vi, and let's say this is D1, D2, D3, and D4, which are the diode 1, 2, 3, 4. So, well, you might see the network drawing like this, right? Equivalent. You have the resistor there. You have this diode, and you have this D3 connected to the source. So D1, D2, D3, and D4. So let's assume that the input voltage is a sine wave, which is an application when we wanted to transform an AC voltage to a DC voltage. Okay, so this is our input voltage. This is a V max, so minus V max. It's not really symmetrical, but can draw it a little better, something like that. Minus V max. Okay, so over one cycle. So what we wanted to do is to draw. So one we're going to draw, we're gonna sketch. Let's just sketch V out on top of V in, top of the input voltage, and sketch the transfer characteristic. Okay, so now as you can see on the positive cycle, the current flows this way, that way, this way, and to ground. So for that case, in that case, when D1, so we have 4 diodes here. So D1 is on, and D2 will be off because of the polarity of the voltage, meaning the D2 will be reverse bias. So this is the IV characteristic of the diode that we're going to use. So the voltage here, that's what we call VD on. So this is ID, and that's VD, voltage and current, so IV characteristic of a diode. So when the D1 is on and D3 on, right, as you can see, V in will be under that condition, V in will be positive. So as we have been doing it, we can write the KVL equation around that, the path of the current, right? So that gives me what? Vi. So, you know, let's just stick to what we have been doing. So let me redraw the network here. And in that case, we have VD on. And then we have the resistor. And we have V VD on for D3, and this. So D2 and D4 are off. Alright, so D2 and D4 will be off. Really, if we wanted to enumerate all the cases, I have 4 diodes, so 2 to the 4. That will be the number of cases that we are going to get. So when we have 2 diodes, I mean we're going to have 4 cases. Okay, so in here we have 4 diodes. All right, but for this 4 diodes, there are only going to be 2 conditions that you're going to see. So we have V in, we'll write our KVL equal to VD on, and that's the voltage across the resistor, VD on plus RID plus VD on. So it's 2 VD on plus RID. So we know that ID in this condition, ID must be positive. So we have VI minus 2 VD on equal to ID. That must be positive because the resistor is positive. So that means when VI is bigger than 2 VD on, then diode 1 is on and diode 3 is also on, right? D2 and D4 are off. Okay, so now what is the output voltage? So VR is a V out, right? So let's make sure we indicate what our output voltage is, right? So that's V0. So V0 will be VR, just RI, okay? So that will be equal to VI minus 2 VD on. Okay, so that when VI bigger than 2 VD on, so that's the condition. Now for the negative cycle of the input voltage, okay, so when VI is less than 2 VD on, well, so let's assume now that so for the negative cycle, so for the negative cycle, what do we have? We have, so let me copy this figure down there. Gotta draw it. It's like that. So we had this, and we had this. We had this, and we had this. So at a negative cycle, meaning the power supply is now this. So the current will flow this way. All right. so the current flows that way. So we still have our V0 here. So let's write the KVL. So we have V in now plus VD on. Draw this so you guys can see. So here we have this diode, and then we have this diode. So VD on, VI. So for this case, the current is flowing this way, ID, right? So we have VI plus VD on plus VD on plus V0. Okay, so VI plus 2 VD on equal to minus V0, which is ID. So we want the current to be positive. That means VI plus VD on, VI plus VD on plus 2 VD on is less than 0. Right, because we want ID positive, so minus ID will be negative. So VI is less than 2 VD on. So for this condition, VL, which is still VL, will be minus VI minus 2 VD on. Okay, so for this condition number 2, we have V0. We have V0, which is equal to negative VI minus 2 VD on. So VI minus 2 VD on, as we have it over there. So that for that condition, we have VI less than 2 VD on. So now let's put it together. So we have V0 equal to the first one is VI minus 2 VD on when VI is bigger than minus 2 VD on, bigger than 2 VD on, so V0. So I mean this, let me copy this down. So I have that, and then we have the second one, the second case, V0 equal to minus VI minus 2 VD on. So VD on, and VI is less than minus 2 VD on. Okay, so now what does the transfer characteristic look like? So let's sketch that. So we have the input there, the V out here. So VI, so let's say this is 2 VD on, and minus 2 VD on. Okay, now so that's this condition is here. So VI is bigger than 2 VD on, then the equation is VI, so VI minus 2 VD on, so that's V0, so it's like MX plus B, so M equal to 1, B equal to minus 2 VD on. So you can sketch this with slope 1. Slope 1. And then when you draw this line, that should be minus 2 VD on. Okay. Okay. And then for the second case, so VI less than minus 2 VD on, right, which is the second case. What do we have? We have V0 equal to minus VI minus 2 VD on. So also it's like MX plus B, so M equal to minus 1, B is minus 2 VD on. Alright, so sketch line for slope -1. Okay, so let's say slope is -1, and then when you draw this line, that's so the line is the transfer characteristic is this. So that's the transfer characteristic. Now, if I wanted to draw the input and the output in the same graph, that's you know what we asked to do as well. So we have, let's say this is my sine wave. So we have Vi bigger than minus 2 VD So for a positive cycle, we have Vi minus 2 VD So this, let's say this is minus 2 VD So Vi So Vi V0 is Vi minus 2 VD So now for the positive cycle, it's gonna look like this. Right, so because we have for the first case, we have V0 equal to Vi minus 2 VD Okay, so when Vi equal to 2 VD then this is 0, right? So the graph starts from here, right? So something like this and that. Okay, so then now Vi for the second case, we have Vi less than minus 2 VD right? So this is minus 2 VD Okay, so for that case, a 0 after that, and then we are going to negate the voltage, right? So it's gonna look something like this. So that's our V0. And the blue is Vi.